All right, y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. So you're going to start with the factoring by multiplying the 5 by the -4 to remove it, and so you're going to have x squared plus x minus 20. And then whenever you go to factor, you're going to replace the 5, and so you're going to have 5x plus 5, and then 5x minus 4. This first set will reduce by 5, and so you're going to have x plus 1 and then 5x minus 4. And so this would be the answer for your factoring question. For the math knowledge question, they tell us that angle A is 50 degrees. We want to know what the other 4 angles add up to be. Well, we are going to use our formula 180 times n minus 2. That's the sum of the interior angles. On this, the n is the number of sides. So we have 5 sides because it's a pentagon. So we're going to do 180. And then 5 minus 2 is 3. And so that will give you 540 degrees. That's the total. If we know that one of the angles is 50, that means that the other 4 are going to have to be 490 degrees. You're just going to say 540 minus 50 degrees. So we are looking at lesson 72 today. We're looking at tangents and circles, part 2. We have already looked at tangents and circles earlier this year on lesson 58. So we're going to be looking more at tangents and circles. I'm going to quickly remind you what a tangent looks like. You've got a circle, and a tangent touches it at one point only. Okay, so if we put our line, that is going to touch it at one spot right here, and so that would be an example of a tangent. We're not talking about sine, cosine, and tangent, not that tangent. This is a different kind of tangent. So hopefully you'll understand tangents and circles after this lesson. So a common tangent is a tangent that is tangent to 2 circles. So a common tangent is actually going to be a tangent line that is tangent for 2 circles. Common tangents can be internal tangents or external tangents. So it can be internal or external. This is an example of internal common tangents. And then this other picture is an example of external common tangents. So internal common tangents, the tangent lines are inside, in between the 2 circles. External common tangents, the tangent lines are outside. They're on the exterior of the circles. Okay? So internal, they're in between the 2 circles. External, the circles are on the inside. The lines are on the exterior. They're on the outside. So looking at this example, given that line AB and CD are internal common tangents to circle M and N, we want to find the lengths of AO and CO. Well, I'm going to remind you, in case you've forgotten, since we have these 2 tangents that meet at a common point, this segment is congruent to this segment. And also, this segment here is congruent to this segment. So we can say either 3x plus 3 equals 5x minus 5, and you can solve that for x. Or you could do 2x equals x plus 4. You can set this segment equal to this one, or this one equal to that one. Either way, you'll have to find your x value, and you're going to get that x equals 4. Or over here, you would get that 2x equals 8, and so x equals 4. And then to find the length of AO, we're going to plug in x equals 4. So we have 3 times 4, 12 plus 3. So the length of AO is going to be 15. Then the length of CO should equal the same thing as the length of AO. So if we say 5 times 4, 20, minus 5 is, in fact, the same. It is 15. And so those are the 2 lengths that you were looking for. Looking at tangent circles. Tangent circles are coplanar circles, so they're in the same plane, and they intersect at exactly one point. Tangent circles can be internally tangent or they can be externally tangent. If they're internally tangent, well, I'll show you a picture of them in a second. In both of the cases, the radii of the two circles are going to be collinear, but they are because they have to be in the same plane. So I'm going to draw two circles, and they're tangent at this point. And here is a radii, and then here is another radii. And so the radii and the tangent point are all on the same line. And so that's what it means whenever it says that the radii of the two circles are collinear. So there's an example of internally tangent circles. One circle is on the inside of the other, so it's internally tangent. And then externally tangent, it's when you have two circles that are tangent and neither one of them is inside the other. They just happen to be touching each other. Okay? So looking at this example, in the diagram, the diameter of circle A is 20, and we want to find the perimeter of our triangle if circle A and circle C are congruent, and the four small circles are all congruent. So, if we know that the diameter of circle A is 20 inches, that means that the radius is 10. So the radius of circle A is 10. But that is also the diameter of a big circle. So that means that this length is 10, and then this one would be 10, and then this one would be 10, because those are all congruent circles. Now, we don't know how to figure out the length of AB or BC, because these two circles don't touch, and so there's no way for us to actually figure out the length here using the radius or the diameter of the circles. What we want to do is to draw this line here, and this length right here is 5 because it's the radius of a circle, and this one is also 5 because it's the radius of the little circle. And so that means that we have a height of a 10. So I'm going to draw a right triangle over here where the height is 10. And then if you look down here, the base of it is 10 and then another 5 from right here. This part here is 5. So the base of this triangle is 15. And then we can use Pythagorean theorem to find the hypotenuse there. And so you can say 10 squared plus 15 squared equals the hypotenuse squared. And so 10 squared is 100 plus 15 squared, which is 225. And so if you add those together, you get 325. And so then you're going to take the square root of both sides. And so if you take the square root of 325, you should get about 18. So our hypotenuse is going to be 18. And so now we can find the perimeter of our triangle. And it says to the nearest tenth. So I'm going to go ahead and round this. It's going to be 18.03. So that I'm not going to end up with a whole number because it asked me to round to the nearest tenth of an inch. So I don't want to estimate here. I'm going to go ahead and make it a little bit more precise. So now I'm going to add. This side length here is 18.03. This side length here is also 18.03 because it has the same height and base for the triangle. And then this bottom piece has a length of 30. So if we say 30 plus 18.03 plus 18.03, and you add those together, you should get 66.06, but it said to round to the nearest tenth. So that would be 66.1. And it's in inches, so our units would be inches. Okay, so that's how that one would work. Looking at the next example, we have a design for a garden. The length from A to C is 70 meters, and they tell us AX is 40, AY is 45. Our two circles are internally tangent, and AC is tangent to both of the circles at point B. And we want to find the length of XY. This is point X right here, and this is point Y right here. So we are looking for the distance right here. Okay? So we know that from A to C is 70. So that means that this piece is 35 and this piece is 35. And then they told us from A to X is 40. So if I draw this triangle, the hypotenuse is 40. And then if I draw from A to Y, the hypotenuse is 45. And so what we need to do is to find the third side, the second leg, for each of those two triangles. So for the red one, I'm going to have 35 squared plus b squared equals 40 squared. And so 35 squared is 1,225 plus b squared, and then 40 squared is 1,600. And so if you solve for b squared, you'll get b squared equals 375. And so then you take the square root of both sides. And you should get that your b value would be 19.36. So that's the length from B to X. Okay? Now we're going to do the same kind of thing, but for the blue triangle. So our side length is still 35 squared, and then we're solving for the other leg. And then our hypotenuse, instead of being 40, is now 45. Because it's just a little bit longer triangle here. So 35 squared is again 1,225 plus b squared, and then 45 squared is 2,025. And so if you subtract those, you're going to get 800. And so you take the square root of both sides. And so you get 28.28. And then to find the distance here between those 2 points, you're just going to subtract these two numbers. And so 28.28 minus the 19.36 gives me 8.92, and it said to the nearest hundredth. So my answer would be 8.92 and then meters. And so that would be your answer that you would use there. Okay? So now let's look at a practice problem. It tells us in the diagram the circles are tangent and RT. You know, I don't think that's the right picture for that one. Let's see if the next one. I have them backwards. All right. Here we go. So RT and QU are tangents, and we want to find the lengths of RS, TS, and SU. So since these are tangent, that means that this segment and this segment are equal to each other. So if this segment is 8 and this segment is x plus 3, that means that 8 equals x plus 3. And so that means our x value is 5. And then we can say x equals 5, plug them into these two segments, and we can figure out what they equal. So this one would be 13, and this one will also be 13. So RS is equal to 8, and then ST equals 13, and SU equals 13. And so those would be your links for your segments they asked you to find. Looking at the next one, we have this figure. We want to find the area of our triangle to the nearest square inch if they are congruent tangent circles with a radii of 6. So if our radius is 6, that means that this length is 6, and then this is a radius, and this is a radius. So that means that the total would be 12. And so tangents are always perpendicular to the radii, so that would be a right angle. And we can use Pythagorean theorem to figure out what the length of RQ is. So we would have 6 squared plus the side squared equals 12 squared. So 36 plus b squared equals 144. And so if you subtract, you'll get b squared equals 108. And so take the square root. And so b would be 6 square roots of 3. And I'm going to point out that this is a 60-degree angle here, and this is a 30-degree angle. And so you actually could have used 30, 60, 90-degree triangle information if you had recognized that it was a 30, 60, 90 triangle. But as you can see, we were able to do it without that information. We can just use Pythagorean theorem. So to find the area of the triangle, we're going to do 1/2 base times height. So your base is 6 and your height is 6 square roots of 3, or you can switch those around. It doesn't matter. And so now you need to just multiply, and it says to the nearest square inch. So we do need to figure it out using our calculator. You don't want to have it as something times the square root of 3. And so if you multiply that, you should get 31.17 or 18, which would still round to 31, and then inches squared. So that would be the answer for that problem. Looking at the last example, a system of pulleys is set up as shown. We want to find the value of x. So on this one, we have 2 circles, and we have 2 tangent lines. As you can see, this tangent line here comes all the way out to A, and this tangent line here comes all the way out to A, and they actually intersect at A. These 2 segments, the 19 and the 5x minus 6, are actually congruent to each other. So all we have to do is say 5x minus 6 equals 19. And so if you add 6, you would have 25, and so x would equal 5. And so that would be the value for x there. These 2 segments that are dotted here and here are congruent, and then this whole segment from A to C is congruent to A to E. And so if these 2 pieces are congruent and the 2 total ones are congruent, that means that this segment has to be congruent to that one. So you can just set them equal to each other to find your x. Okay, so now we're going to look at the challenge question. So y'all can pause the video and think about this one for a minute, and then y'all unpause the video and I'll go over the answer for you. It wants us to prove that x, y, and z are collinear. It tells us that line AB is tangent to all 3 circles at point C. And so I'm going to read to you what the book has to say. You may have understood it and you may not have. It's okay if you didn't. It is a challenge question. But it tells us that tangent lines are perpendicular to radii at the point of tangency. So that means that angle XCA equals 90 degrees, because XC is a radii, so XCA is a 90-degree angle. Also, YCA is a 90-degree angle, and ZCA is a 90-degree angle. All of those are perpendicular to line AB because they make a 90-degree angle. That means that y and z are collinear because we can just pick and say, hey, two lines are always going to be collinear. I mean, 2 points are always going to be collinear. I drew a line between them, and they're collinear because 2 lines always define a point. Since there's only one line through a point that is perpendicular to a line, that means that y and z must both be perpendicular to line AB. So they lie on the same perpendicular line to AB. And then, since the measure of angle XCA plus the measure of angle YCA equals 180 degrees, because they were both perpendicular, that means that XY has to be a straight line. It has to be 180 degrees, because this angle here and this angle here were 90 degrees. So we have a straight line here, straight angle. And so those are a linear pair, which by definition means that they are collinear. And so that means that X has to be collinear with Y and also collinear with Z. And so that would be how they explained it. They didn't do a 2-column proof, they did a paragraph proof. But that's basically what you do with those. Okay, so that is dealing with tangents and circles part 2. Your homework is 1 through 30. So you need to make sure you do that tonight so that we can go over any questions you have tomorrow.